Hi everyone. In this lesson we're going to see an introduction to another type of transformations, which are rotations. A rotation is a transformation that turns a figure a certain number of degrees around a fixed point called the center of rotation. So we're going to be turning a figure. It's very important that we're able to identify the type of movement that is done in each type of transformation. For example, when we have a translation, we're dragging a figure from one place to another place. When we have a reflection, we're creating a mirror image of a figure using a line as the mirror. And in a rotation, we're turning a figure around a certain point, which is called the center of rotation, in a certain number of degrees. So if we're doing that movement, turning, the movement could be done clockwise. That means according to the movement of the clock, which means you're kind of moving sort of to the right, like this. Or it could be done counterclockwise, which is the opposite of the movement of the clock, which is sort of to the left, that way. And actually, in math, it is conventional to always do it counterclockwise. So unless the instructions tell you very specifically that they want a clockwise rotation, it's always going to be counterclockwise. If the instructions do not mention the direction, it is because it is clockwise. So most of the times, we are not going to be doing this type of movement. We're always going to be doing a counterclockwise rotation. So with the diagram that I have here on the right, I'm going to just show you more or less what rotations are. So in this case, I have a figure, triangle PQR, and point C, which is going to be, for me, the center of rotation. So we're going to be rotating this figure, taking point C as the center, and I'm going to be rotating, let's say, 90 degrees. And that's going to be counterclockwise. We always do it counterclockwise. And if I do that, the figure will end up somewhere over here. Let's say somewhere here like this, where this would be P prime, this would be Q prime, and this would be R prime. So I'm moving 90 degrees sort of to the left side, counterclockwise, based on point C, which is the center of rotation. So right now I'm not explaining how to do it. We're going to see that later on. I'm just showing how it would end after the rotation. But some of the important properties that we need to remember or that you need to check, for example, here, if you connect point P to the center of rotation, which is C, and then you connect point C to point P prime, you should be able to see the angle of rotation, which is 90 degrees. So let me do that. I'm going to connect point C to point P, and then point C to point P prime. It's not very exact, but you could see over there more or less the angle. So whenever you do a rotation, what you see here would be the angle of rotation. So in this case, we are moving clockwise like this, counterclockwise, sorry. And so that is over there the angle of rotation. And whenever you connect a point to the center of rotation and the image of that point to the center of rotation, you should be able to see the angle over there. And another thing that's important, the distance from P to C should be the same as the distance from P prime to C prime. In other words, a point and its image are both equidistant from the center of rotation. So I'm marking that here. This is congruent to this. So BC is congruent to B prime C. That is always the case whenever you connect any point and its image to the center of rotation. That will be true. For example, the distance from R to C would be the same as the distance from R prime to C prime, and the same for Q. QC would be the same as Q prime C. So now we're going to see the rules of rotation that are going to be used whenever we're rotating in the coordinate plane. So here we just did a rotation, not necessarily in the coordinate plane, just agreed, but now we're going to see the rules for rotations on the coordinate plane. Again, the rules over here. These are the rules for rotating a figure counterclockwise around the origin. Two important things here. These are only for counterclockwise rotations, and they are only for those rotations where the center of rotation is the origin. That means the point 0, 0. That is the center of rotation. So these rules only work in this case. Counterclockwise rotations, and the center is the point 0, 0. So here's the first rule. If you are rotating 90 degrees, in this case, counterclockwise, the point xy is going to change to negative y, x. So look at what happens. It's x, y, and now this is negative y, x. Very important here, the negative that we see over here does not mean that the number is going to be negative all the time. That is not what it means to have a negative here. It just means that the value changes the sign compared to the original value. So in this case, the value of y is going to change the sign. So if this original value was negative, that's going to become positive. But if this was positive, that's going to become negative. So a negative means a change in sign, not that the number is going to be negative all the time. So we see that the value of y is going to change its sign, and also the positions are going to change. From x to y now changes to y, x, and the y value changes its sign compared to the original value. So in this case, if we do that, a prime should be this. First thing that we need to do, we need to exchange the place of the x and the y. So the 5 is going to go first, and the 4 is going to go second. Notice that the value of x stays exactly the same, only in the place of the y. So this is going to be 4. And now the 5 is going to be here, and it's going to change the original sign. It was negative, so now it should be positive. So the image of A, which is A prime, should be 5, 4. Let me just show very quickly what it should look like on the coordinate plane. For example, just approximating the original point A should be 4, -5, let's say somewhere over here, 4, -5, that should be A. And so if you're moving 90 degrees counterclockwise, this should go from the fourth quadrant to the first quadrant, because that's going to be a counterclockwise direction movement in 90 degrees. So it's going to come somewhere over here. And if we look at this one, that is actually here. So that is 4, sorry, it's 5, 4. So it's going to be somewhere over there. And that's going to be A prime. It's not a very exact graph, it's just a sketch. But if you connect this point to the center of rotation, which is the point 0, 0, the origin, and then you connect it here, you sort of see over there the angle of rotation, which should always be the case. Not very exact, but you can see more or less. So now we're going to do example number 2. We're going to be rotating again 90 degrees and finding the image. We're just going to do it algebraically. We're not going to be graphing. So it's B prime. It's going to be, so first we need to exchange the place of the x and the y. So the x is going to be here and it stays the same. So it stays +6. And the y changes to the place of the x, and it also changes the sign. So it was +9 before, it should now be -9. So B prime, the image of B after a rotation of 90 degrees counterclockwise is -9, 6. Now the rule for 180-degree rotation is every point xy changes to -x, -y. So notice what happens. The values of x and y stay in the same place, but the sign is changed for both of them. So you do not need to exchange the places of the x and the y. You only need to change the sign compared to the original values of x and y. So that's going to be relatively easy. So in this case, C prime, the values of x and y stay in the same position. So 5 stays in the same position, 3 stays in the same position, only the signs are changed. So this was negative, now it should be +5, so we leave it as +5. 3 was positive, so now it should be negative over here, -3. D prime, we leave the x and the y values in the same place. We only change the signs. So we have 2 negatives, so that means both of the numbers should be here positive. So that should be +2, +7. The next one is a rotation of 270 degrees counterclockwise, having the center as the origin. And the rule says that every point xy changes to y -x. So one more time, the values of x and y are switched. So you need to switch the positions. The value of y stays the same as it was in the original point, but the sign of the x value changes. So with that, we can find E prime. We need to switch the places of the x and the y. So 8 is going to be here, 5 is going to be here. What was y, which is the 8, stays the same with the same sign, and the 5, what was x, should change the sign, so it should become here negative. So it's 8, -5. And finally, point F, f prime. So we switch the places of the x and the y. So here should be 6 and here should be 2. Now the y should stay the same. So that means this -6 should be here still negative. And the value of x is going to change. So this that was positive should be negative over here. So we end up with actually both being negative in this case. Okay, so those are the rules to rotate a figure on the coordinate plane. I just want you to practice applying these rules so that in the following lesson we can actually do the rotations. Notice that we only are rotating 90, 180, 70. It's 90 and the multiples of 90, 90, 180, 70. A rotation of 360 degrees will move the point back to the original position, so we don't do that. But we're only doing these rotations because they are relatively easy, and still we have a lot of memorization to do with these formulas, and using any other number of degrees is going to be almost impossible to do. So we only do 90, 180, and 270 degrees. So I'm going to leave you the practice exercises that are here. All of them must be done in the counterclockwise direction because it doesn't say anything. If it doesn't mention anything, it's because it's counterclockwise direction, and all of them are centered in the origin. And remember that the rules that we have here are only for those types of rotations. So if you want to do another type of rotation like clockwise, you will have to sort of discover the rules for clockwise and do them, but we are not going to do that in this class. So complete these practice exercises and send it to my email address so that I can see that you were able to do them or not, and then you should be ready for the next class. So that is for today's lesson, just applying the rotation rules in order to rotate a figure on the coordinate plane.